What if our galaxy, with its hundreds of billions of stars, is just a grain of sand? Stepping outside at night, gazing at the Milky Way, we feel an overwhelming cosmic scale. Our galactic home spans roughly 100,000 light-years across. It shelters between 100 and 400 billion stars and countless planets. To human minds, the Milky Way feels infinitely huge, an unbounded island of starlight. But in modern astrophysics, our galaxy is merely a local neighborhood address. Just beyond the outer edges of the Milky Way lies an unimaginable vastness. This vast emptiness makes our entire galaxy look microscopic by comparison. Beyond our borders, galaxies cluster together in cosmic families and gigantic superclusters. How large is the universe when we look outside our own galactic walls? Where does our galaxy sit inside the grand architecture of reality? Today, we step off the edge of the Milky Way to measure the cosmos. Prepare for a mind-bending journey across the structure of deep space. Let us venture deep into the dark sea of the intergalactic void. Our journey outside the galaxy begins in our immediate neighborhood, the local group. The local group is a gravitationally bound cluster containing over 50 galaxies. Most of these are tiny dwarf galaxies, but two giants dominate the region. Our Milky Way is one giant, and Andromeda is the other, even larger Titan. Andromeda sits roughly 2.5 million light-years away from us. Between us and Andromeda lies a vast expanse of dark intergalactic space. Yet, despite this enormous gap, gravity holds our local group tightly together. In fact, the Milky Way and Andromeda are currently rushing toward each other. In roughly 4 billion years, these two giants will merge into one. This merger will create a single, massive, elliptical galaxy in the far future. But as huge as the local group is, it is still small. Spanning 10 million light-years, it is merely a tiny village in deep space. This local neighborhood is just the first step on our journey outward. Beyond this cluster lies a vast ocean of light and empty space. Gravity connects these distant structures across millions of light-years of darkness. Now, let us zoom out even further to find where we reside. Zooming out further beyond the local group reveals an even larger structure. This structure is known as the massive, glowing Virgo supercluster. The Virgo supercluster contains a massive collection of over 2,000 galaxies. Our local group sits near the outer edge of this massive cosmic concentration. In 2014, astrophysicists mapped cosmic gravity flows and discovered something grander. They discovered Laniakea, a term meaning immeasurable heaven in Hawaiian. Laniakea is our immense home supercluster of over 100,000 galaxies. This incredible structure spans over 500 million light-years across. Within Laniakea, galaxies do not drift randomly through the dark void. Instead, they flow along glowing, complex gravitational pathways of cosmic gas. They are slowly drawn toward a dense gravitational center, the Great Attractor. This gravitational anomaly pulls thousands of galaxies through the dark expanse. If you compare the universe to a giant, ancient oak tree, then Laniakea is just one single, glowing branch of that tree. And our entire Milky Way is merely a tiny leaf resting on it. But even Laniakea is just one part of a much larger cosmic web. Our journey continues as we peer into the grandest scales of existence. Beyond this cluster lies a vast ocean of light and empty space. Pulling back to the largest scales, the universe reveals its true architecture. Matter is not spread evenly across the vastness of deep space. Instead, it organizes into a structure called the giant cosmic web. Trillions of galaxies are woven into long, glowing filaments of starlight. Where these filaments intersect, dense galaxy clusters form like giant cosmic cities. Between these glowing strands lie vast, dark spaces known as cosmic voids. These voids are immense bubbles of near-absolute emptiness in deep space. They span hundreds of millions of light-years with almost no matter. The Boötes void is so vast, light takes 300 million years to cross. It contains almost no galaxies, representing a silent, empty cosmic desert. If you stood in its center, you would see absolute darkness. The universe at this scale resembles a gigantic sponge made of starlight. This web represents the cosmic skeleton of all matter in existence. It stretches continuously across billions of light-years of cold, dark space. Now we must ask, how far does this magnificent pattern stretch? Let us reach the absolute limits of what we can observe. This brings us to the ultimate question of cosmic scale. How big is the total observable universe beyond our galaxy? Because light travels at a finite speed, our view is limited. We can only see regions whose light has reached us since the Big Bang. Due to the expansion of space, the observable universe has stretched. This expansion has occurred over 13.8 billion years of time. Today, the observable universe forms a sphere 93 billion light-years wide.
Inside this observable sphere lie an estimated 2 trillion distinct galaxies.
Each galaxy contains hundreds of billions of glowing stars and planets. Beyond this boundary lies the vast and mysterious, unobservable universe. These are regions whose light has not had time to reach Earth yet. This web represents the cosmic skeleton of all matter in existence. Our galaxy is a single speck, floating in an ocean of infinite creation. In an infinite cosmos, everything we know is just a microscopic point. Measuring the universe beyond our galaxy reveals a reality vast beyond imagination. Realizing our smallness does not diminish us. It highlights our incredible human wonder. We are a tiny part of the universe that can observe itself. Which scale of the universe amazed you the most? Share your thoughts below. Subscribe for more cosmic journeys and keep exploring the grand design.